What if everything we believed about space, time, and the very nature of reality was fundamentally flawed? What if, rather than merely revealing distant galaxies, the most advanced space telescope in human history had unknowingly opened a doorway, one that perhaps was never meant to be found? The James Webb Space Telescope has already captivated the world with its breathtaking images of the early universe. But its latest findings suggest something far more profound than cosmic beauty. Hidden within the stream of data is something deeper, something stranger, a disturbance, or perhaps a pattern concealed within the very fabric of space. It behaves like a glitch in the cosmic code, or maybe even a glimpse into dimensions we've only theorized in mathematics and dreams. Collaborating across disciplines, scientists from a quantum research lab, alongside theoretical physicists and astrophysicists, uncovered signals in Webb's data that defy explanation. These weren't ordinary light patterns. They broke expected models of physics, showing repeating frequencies and structures that echoed across space like a silent, multidimensional rhythm. This discovery could do more than rewrite textbooks. It could alter our understanding of reality itself. It all began with a routine scan of a Bell 2744, a well-known galaxy cluster recognized for its gravitational lensing effects. But this time, something in the data defied expectations. As light filtered through the telescope, subtle distortions appeared barely perceptible, shimmering just at the edge of what could be detected. Rather than chaos, the light formed patterns that held mathematical regularity hidden beneath what should have been random cosmic noise. These formations weren't the result of gravity, interstellar gas, or galactic motion. They were too precise, too symmetrical. At first, researchers thought it might be an error. But the anomalies reappeared in observations of entirely different regions that changed everything. It appeared as if something was guiding the light across the cosmos, something intentional, something structured. Traditional physics couldn't explain what was happening. So the scientists turned to quantum algorithms, leveraging advanced computational methods to see what classical systems could not. The data was fed into quantum-optimized models, and what came out left them stunned. The irregularities weren't only real, they reflected mathematical structures predicted by string theory. They pointed to additional dimensions, spaces curled so tightly that they're invisible to the human eye. These quantum algorithms, operating through qubits that can model overlapping states of reality, identified frequency patterns that aligned with theoretical models of 10 or even 11 dimensions. It was as if the telescope wasn't just capturing light, but the shadows cast by higher dimensions, something beyond our known universe, reflected back in subtle geometry and frequency. Suddenly, once abstract theories began taking form in the data, Harvard physicist Lisa Randall offered a powerful perspective. What if some of these hidden dimensions aren't sealed off completely? Under certain cosmic conditions, perhaps the boundary between worlds becomes thin enough for something to leak through. This would explain why gravity behaves so weakly compared to other forces. It may be dispersing into other dimensions. For the first time, there was tangible evidence that reality might be layered, and that we had just peeled back the very first veil. The photons traveling billions of years to reach us weren't moving through empty space, but through folds, curvatures in spacetime that refracted and twisted them, not at random, but with clear symmetry. These distortions weren't chaotic. They resembled a signature, an encoded fingerprint left by something beyond our dimension. It raised a profound question. What if the universe isn't merely expanding, but resonating? And what if we are the first beings in history capable of hearing that resonance? Here's where it gets even more personal and unsettling. If string theory is correct, then every part of you, your thoughts, your voice, your very cells is made of vibrating threads of energy stretched across multiple dimensions. The strange frequencies picked up by Webb and interpreted by quantum analysis weren't alien, they were reflections of us. Echoes of the multiverse humming inside our very bones, across space and in the background radiation of the universe itself. Quantum AI detected recurring harmonic string-like vibrations that matched theoretical predictions. Imagine listening to a distant orchestra and suddenly realizing one instrument is playing your own musical note. The implications are staggering. Our consciousness, our choices, might ripple into hidden layers of the cosmos. And if those ripples return, how would we even recognize them? For decades, cosmologists relied on the so-called cosmological constant to explain the universe's accelerated expansion, a mathematical plug Einstein once called his greatest mistake. Yet new data from deep-field images challenges that view. Redshift readings from far-flung galaxies are too erratic, too inconsistent to match the models. The expansion isn't just speeding up. It's behaving like a living system, fluctuating, pulsing, reacting. Some physicists now suggest that what we've called dark energy might not be a force at all. It could be a message, a coded movement that responds to how we observe it. Could it be that by watching the edge of the universe, we're not simply measuring it, but interacting with it? And then there's dark matter, that invisible scaffolding we've long believed holds galaxies together. Webb's high-resolution spectrographic imaging peered deeper into galactic halos than ever before, but instead of confirming dark matter, the readings showed that something was missing. Gravity wasn't behaving as expected. Not because the data was wrong, but because the force itself may be shifting, bleeding into dimensions just out of reach. Perhaps dark matter isn't gone. Perhaps it's somewhere else. The most chilling discovery came next. A deep skin near the Eridanus supervoidal, unusually cold, empty region of the cosmic microwave background revealed something entirely unexpected. Not a galaxy, not a star, not even a black hole, just ... structure, isolated, geometric, too perfect to be natural. It emitted no light, cast no shadow, but distorted every wavelength passing through it. Internal communications from international space agencies referred to it cryptically as the anomaly. Attempts to scrub or obscure the data failed. Independent researchers managed to download and analyze it before access was restricted. Their findings were unsettling. The object resembled a ring or frame, possibly a lens, possibly a doorway. Most disturbingly, it hadn't been visible in previous scans. Whatever it was, it had appeared recently. In the shadows of all these revelations lies a theory too controversial for most academic journals to publish. Whispers among scientists now entertain the possibility that consciousness itself is woven into the cosmos, that the act of observation is not passive, but participatory. The repeating harmonics, the multidimensional echoes, what if they're not just signals, but responses? What if the universe was waiting for us to evolve far enough to see it, and now that we have, it's seeing us back? Some call this the observer effect, others invoke more ancient ideas. But one thing seems increasingly undeniable: the latest images from Webb don't just reveal the past. They reflect us watching ourselves from the outside. As if something or someone is watching the watchers. The James Webb Telescope was designed to see farther into the cosmos than any instrument before it, but no one expected that in doing so, it might also pierce into something not just ancient but aware. With each image, each spectral map, each vibration, it hasn't merely collected data. It has uncovered patterns, structure, and perhaps even intention. So what if the universe isn't a fixed object, but a living process? What if reality isn't here for us to decipher, but to respond the moment we begin trying? From shifting constants to invisible dimensions, from altered gravitational laws to impossible geometries, Webb hasn't just observed anomalies. It may have triggered them, and maybe that's the deepest truth of all. That science hasn't failed, it's evolved. And in doing so, it's shattered our illusion of control. Because in our relentless pursuit to understand everything, we may have just shown the universe that we are finally ready to be understood.